As we go on to start Chapter 7, Section 1, we're going to be dealing with radical expressions, functions, and models. Now, when we think of the term radical expressions, it's something to do with something under the radical sign. That's what this sign is called, the radical sign. Now, what is under the radical sign is called the radicand. So right now I've put 4a squared under the radical sign. Now keep in mind the radical sign is also a grouping symbol. Things that are under it are taken together, and it tells you to do something. This is an operation sign as well. It says take the square root, in this case, of this radicand. Now another thing we should note too is that in this little notch here of the radical sign, if we don't see a number there, the number that is assumed to be there is a 2. This is what is called the index or the index number. So this is the radical 2 of that, or sometimes said square root of that. Now, if it is another number, again, if it's 2, we don't write it. If it's another number, we have to actually physically put it there. Now, there never is a 1 there. In this case, when there's no number, it's a 2. Okay. Now, we'll be looking at cube roots too, in which there'll be a 3 there, and then odd and even roots and some other little properties of them as we go on. But have these words in your notes. They're going to be very significant, will be part of the vocabulary that we use. Now I'll raise it up. So they're asking us now, again, there is the radical sign. There's the radicand, the index number is 2, and they're saying take the square root of 49. Well, what two factors are the same that when they're multiplied together give you a 49? Well, it's 7. Now, keep in mind also it could have been a negative 7. So if you square a negative 7, you also get 49. But right now they're asking for what they call the principal square root, even though they haven't mentioned it there. So for a fraction like this, you take the square root of 9, which is 3, the square root of 100, which is 10. And remember that could have been a negative 3/10 squared to give you this, but the principal square root. Now here we have the square root of 16, which is 4. And then, like before, we take our negative sign, and we now apply the negative sign. So we do the function, we get 4, and we apply the negative sign. And here note there are 4 decimal places. So the square root of 4 is 2, but in order to get 4 decimal places, we have to add a 0 there and then another for a placeholder. And if you multiply this by itself, you get this. Now here what they want us to do is to substitute a value in there and then carry out the process. So we're going to put 5 times 7, which is 35, plus 1, which is then the square root of 36, which is 6. Here we're going to put the 20 in there. 4 times 20 is 80. 80 minus 3 is 77. 4 times 20, 80 minus 3. Again, this is a grouping symbol. You do what is under the radical first. You get the square root of 77. Since this is not a perfect square, we just leave it, and then of course we need to apply the negative sign. Now in number 2, I should say, we're saying simplify each expression. Assume that the variable can represent any real number. So here we're thinking it could represent a negative that was squared. So here we have the square root of 81, which is 9, and the square root of z squared, which is z. Now, to assume, and here's where there's a little conflict here, the book is showing that it's just this that has the absolute value because you don't know what would have gone on there. I personally would have thought it would have been 9z like so, because that could have been a negative. This would have caused that to happen too. So generally speaking, you need to be careful and keep this in mind that by placing the absolute sign there, you're including the possibility of a negative value squared that would have given you a positive. In letter B, do you recognize what's under the radical sign, this radicand? And the answer is, yeah, that's a perfect square trinomial, which factors into y minus 3, the quantity squared. So that would be what you would find under the radical. And then by taking the square root of it, they're saying, well, that could have also been a negative. We take away the square root sign, the square sign, and then put our absolute value around. Now for this next one, here we're taking the square root of x to the 12th. Now remember we had said there was a 2 there that we don't put. Now something we're going to show you in the next section that might be useful here is this is the radical form. There is another form of this that we'll be studying in the next section where we take away the radical sign. We get our radicand now becomes the base. The 12 is there, but this index number becomes the denominator of the exponent. So we'll show you this in more detail in the next section. But what is that going to become? Well, x to the 6th. So if mentally, you sort of take away the radical sign, take your index number and divide it into the exponent, that will give you 6. is a better answer. There we go. So 12 divided by 2 is 6. There we go. All right, for each function, find the indicated function value. Okay, we're going to multiply now the 2 by the 32 and get the cube root of 64. Now you may or may not know that, but the cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. Now, for this next one, we're going to put a negative 128 under the radical sign to replace n. Add 3 to it, so it gives us a negative 125. Now, something they haven't shown us, but they will, I'm assuming, sooner or later, is that are we allowed up here, if we had, let's say, the square root of negative 4. Now again, our index number is 2. And you might say, is there such a real number that is the square root of negative 4? And you might say, well, negative 2. But negative 2 times negative 2 is a positive 4. Well, 4. But 4 times 4 is or 2 times 2 is a 4. So there are no two numbers that when you multiply them together will give you a negative value. So we say that when we are tasked with the square root of a negative number, there is no real number solution for that. So we say no real number solution to something like this. So they didn't give us this, it's probably in our textbook, but when we go to this one now and we see the cube root of a negative, is that possible? And the answer is yes, it is, and that's okay. Odd number index numbers that have a negative under the radical sign, that's okay, because the answer to this is negative 5. Because a negative 5 times a negative 5 times a negative 5 gives you a negative 125. Odd number of negative signs give you a negative. So as long as the index number is odd, it's okay. If the index number is even and there is a negative under the radical, that is not a real number. Okay, so we've done a few of these. Let's do our next one before we raise it up. Now here we have a negative 27. It's a third root, an odd index number, so that's okay. Negative what? Multiplied by itself 3 times gives you that. Negative 3. Now again, take the index number, divide it into your exponent, and you get x to the second. Again, we'll be doing that in the next section, but it's a useful tool. Okay. Now, again, they're saying simplify It's any real number. So the fifth root is odd, so it's okay to have a negative. And you may or may not know this, but this is negative 3. Negative 3 to the fifth power is this. Now here we have the fourth root of 81, and that happens to be 3. And then the fourth root of x to the fourth. Again, dividing this 4 by this 4 just gives you x. And your answer key is indicating that they do want that x in absolute signs, because it could have been a negative value. Well, it could have been a negative value there as well that you're raising to the fourth. Now, here, for letter C, if you take that 6 divided by that 6, it's going to give you just the radicand, x minus 5. And again, they're saying that could have been negative, so they want you to put it in absolute value terms. And now you apply the negative. So that's the value for C. Now this is odd. This is odd. We're just going to divide 9 by 9 and we get A. Now, why do we not put the absolute values here? Well, we only put absolute values if it's an even index number. Odd index numbers, remember, it's okay for them to have negative values. Again, this is negative. I'm sorry, this is odd, and this is 7. So 7 divided by 7 just gives you the radicand. No absolute value signs needed. Here's where they give us the case of an even index number, but a negative radicand. Now that is not possible. So no real number solution. Not a real number. Okay. All right, going on now to number 5. Here they want us to determine the domain of each function. Now, remember, we cannot have a negative value under the radical sign if it's an even root number, index number. So, the smallest value we can have under the radical sign is 0, because as it gets smaller than 0, it's negative. But 0 is okay. Now, notice what's going on here, though. Is there any chance, once we square x, for there to be a negative value under the radical sign? Think of it for a moment. If we have negative 5, negative 5 times negative 5 is 25. So the answer is no, because whenever we square a number, if it's 2 negatives or 2 positives, it's always going to be positive. So we say the domain then for something that is squared is negative infinity to positive infinity. That is all real numbers. And that's what they have right here. Now, how about letter B? Now, letter B has an index number of 2. So, again, you can't have a negative number. So for those, we just go x minus 5 equals 0, and it has to be greater than or equal to 0, because if it's less than 0, it becomes negative. So we just go x is greater or equal to 5. And then how do we put that in interval notation? Well, it starts with 5. We're using a bracket because 5 is included, and it goes to positive infinity. And infinity always has a parenthesis. Now, again, this is an even index number. So we just do the same thing. I'll do it down here. 15 minus 2x equals 0. And it has to be greater than or equal to 0. Now notice your x term here is sort of, well, is multiplied by a negative. So in most cases, if you have a negative value for x, this is going to become positive. But we have to see specifically where it's going to start. So the first thing I would do, I would transpose my negative 2x to the other side, and I get 15. Divide both sides by 2, and then I'm going to write it this way. X is less than or equal to 15 halves. Now again, on a number line, 15 halves would be right there. And what sign do we indicate on our number line? Well, we're going to put a bracket because that's included in the set. And it's less than, so it's going this way. Now, how do I put that in interval notation? Well, it's coming from negative infinity, going up to 15 halves, and 15 halves is included in the set. And that's what we have here. Okay? Now, keep in mind, why are all these negative values included? Because whatever negative value you put for x, negative times a negative makes this a positive. Okay. All right, let's go on to our last one. Here's a fella has a sign shop, and we say his profit is based on this. When P is the profit in thousands of dollars, T is the number of years since 2000. We want to know the profit in 2015, actually this year. This is the year. And how many years? 15. So we then go 34 times the square root of 15. We put that in our calculator, and keeping in mind it's thousands of dollars, we end up with this answer right down there. And we do want you to try it on your calculator. Hopefully you know how to do this. And a quick reference is when we're taking any of these kind of fifth roots of something, if we want to put that in our calculator, it looks like this. You put a negative, you could put a parenthesis there if you'd like, 243, and then you convert. If it says the fifth root, we put the caret sign, which is one of the signs on our calculator keys, and then we just put a parenthesis and we go 1 over 5. 1 divided by 5, parentheses, hit enter, and it gives you a negative 3. And you can try that out too, and it works for all of them. If you put 81 caret 1/4 in parentheses. That will give you 3. Okay, we'll be going on to 2 here very shortly in about 25 minutes.